Hey guys, this is a follow-up video to show you how to calculate variance, so it follows on from our discussions with the normal distribution. So I've gone out and I've taken some samples of the numbers of cars which were in this random parking lot which I found over the course of the past week. So this is the number of cars which were there on the given days. And that's 1 week, so I have 7 observations in my 1 week. So to calculate the variance, it's a pretty straightforward calculation-based process, and we'll be using a formula which looks like this. Sigma squared is equal to the sum of the x observations, take the mean x squared divided by n. And sigma squared is just the notation which is used, so it's a nomenclature for the variance of a set of data. So to work out this variance, we're going to use this formula. And it may look quite complex, but it's actually a straightforward calculation to work out our variance. And after we've got our variance, we will calculate our standard deviation. So sometimes what will happen is the VCAA questions about calculating variance and standard deviation will actually involve this calculation. So for our purposes, this calculation is demonstrative of the type of question that we will get from VCAA. So what we want to do is we want to start to calculate variance just by using this formula. So to begin with, I guess it's quite helpful to really draw up a table, and you can put your x values in one column, and we put our mean in the next column. In the next column we will put our x take our mean, and in the next column we'll put the squared values of that mean, of those deviations, I'm sorry. So if we draw this up, we know we've got a total of 7 observations, so I want 7 rows in this column. So our first observation of x is 10, second is 15, third is 20, fourth is 15, 10, 15, 20. Right, so this is what our table will look like. Right, so first thing we're going to need to do is calculate the mean, so we can fill in this first column. So to calculate the mean, we're going to use the formula for the mean. So the mean, which we denote as x bar, is equal to the sum of the observations divided by the total number. So we know we've got a week, so we know that the denominator, there'll be 7 observations because we have 1, 2, 3, 4, 5, 6, 7 observations. So 7 is going to be our denominator. And we will simply add up all of the observations to get our sum of observations. So 10 plus 15 is 25, plus 20 is 45, and so on and so forth. And if we keep adding the observations, so we add that to that to that to that, we'll get a total of 105. And if we divide 105 by 7, we'll find that our x bar is equal to 15. So then we can go through and we can fill in this next column. And we can say that our x bar is 15. So these are all the steps we need to do to calculate variance. So next we're finding what's known as the deviations from the mean. So this is our mean, and this x is our deviations from the mean. So to calculate the deviations, all we do is we take our x value and we minus our x bar value. And we don't take the magnitude, we take the actual value which we obtain. So to begin with, we have I'll draw it over here if you'll follow along. So I'll go from here over to here. We have x equals 10 and x bar equals 15. So x minus the x bar is going to be 10 minus 15, which is equal to negative 5. So I'll put negative 5 there. For our second column, x will now be 15, and x bar will be equal to 15. So we have 15 minus 15, and that's 0. So our second row, we have 0. And we just purely repeat this process down the entire column. So we'll get 5, 0, negative 5, 0, positive 5. Nextly, what we need to do is we need to square these deviations from the mean. So in order to do that, what we do is we take this deviation which we have here. So for our first observation, our deviation is -5. And we just square it. So to do that, we'll square both sides of these equations. So that will equal to 25. So remember that when we are squaring a negative number, so when we have -5 times by -5, these two negative signs cancel out to become positive signs, and we end up with a positive number. So just bear that in mind whenever you're squaring negative numbers, you will get a positive number after you have squared it. So if you've got any negative numbers in this last column, go back and check and make sure you've done your workings correctly. So we also know that 0 squared is just equal to 0. Nothing times nothing is nothing. 5 squared is 25. 0 squared is 0. -5 squared is 25. 0 squared is 0, and 5 squared is 25. So when we get to the end of that, we realize that we have now the squared deviations from the mean. So we are only one step away from having our variance. What we need to do now is to use this formula which we've derived up here to calculate our variance. So we know that our variance is equal to the sum of our squared observations, deviations from the mean, divided by the number of observations we have. So we've already worked out the individual deviations from the mean squared. So in order to get the sum, all we do is we add all the numbers in this last column, which I'm just going through now. So if we go through and add them all together, we'll find that we have 25 plus 0 plus 25 plus 0 plus 25 plus 0 plus 25, which is 100. So that equals to 100. Then all we do is we take our sum of the squared observations and we divide it by the total number of observations which we had, n. So because I know I had a week worth of observations, n is equal to 7, our variance will be equal to 100 divided by 7, and that's roughly 14.3. And I've rounded that to one decimal place. So that is how we calculate our variance. Once we've got our variance, it's actually quite straightforward to calculate our standard deviation. So I'll leave this formula here. I'll just get rid of this table. And I'll get rid of all this. So what we've just worked out is that our variance for this set of data is equal to 14.3. Now the variance is the standard deviation of the sample squared. So I denoted variance as this sigma squared. We often denote our standard deviation as just a plain sigma. We denote, standard deviation as this plain sigma equals standard deviation. So that means in order to get our standard deviation, we need to take the square root of the variance. So if we have our variance is equal to 14.3, we have this, 14.3 equals sigma squared. We're just going to do some algebraic manipulation to get our standard deviation. So if sigma squared is equal to 14.3, we need to square root to get our standard deviation. So our standard deviation will be the square root of 14.3. So that's just me square rooting this number here, this 14.3, to get my standard deviation. So the standard deviation for this data set is equal to 3.78, and I've rounded that again. So that's how we calculate the variance and the standard deviation. Be mindful when you're asked in questions whether they ask you or give you the variance or the standard deviation. The standard deviation is just the square root of the variance, and the variance is just calculated as we did so before. Thanks for joining, guys. I'll see you next lesson.